Hello students, today we are going to discuss the 12th numerical. Question is written as the moments at the ends A and B of a beam AB where end A is fixed and B is hinged when the end B sinks by an amount delta are given as. Here a beam is shown whose support A is fixed and support B is hinged. Now we need to determine the moments at end A and end B when the support B sinks by an amount delta. So we have synced the support B by an amount delta and we will get the moment at both the ends as 6 EI delta upon L square in the anticlockwise direction as well as 6 EI delta upon L square in the anticlockwise direction. Now we know that hinge support is not capable of resisting any moment, so we had to make the net moment at hinge support equals to 0. Now here to balance this anti-clockwise moment, we need to apply a clockwise moment of equal amount, that is 6 EI delta upon L square. Okay, now the net moment at this support B will be equals to 0, but we need to transfer the carryover of this applied moment to the fixed end. So we need to transfer the carryover of this moment to the fixed end and it will be acting in the same direction of half magnitude, which will be equals to 3 EI delta upon L square. So the net moment acting at A, net moment acting at support A will be equals to the difference of 6 EI delta upon L square and 3 EI delta upon L square. It will be 3 EI delta upon L square acting in the anti-clockwise direction, because 6 EI delta upon L square is greater than 3 EI delta upon L square, and net moment acting at B will be equals to net moment acting at B will be equals to 0, because the anti-clockwise moment of 6 EI delta upon L square is balanced by the clockwise moment of 6 EI delta upon L square. So the net moment acting at support B will be equals to 0. So due to the sinking of support B by delta amount, the moment generated at end A will be 3 EI delta upon L square in anti-clockwise direction and at B will be 0. That is all about this numerical. Thank you very much, students.